On Venus, 1 million volcanoes are believed to be inactive. But we finally captured a real eruption. Venusian volcanism has long been the subject of study and debate among scientists, questioning whether it is still active or has ceased millions of years ago. The early space missions spanning from the 60s to the 80s provided images of Venus's surface, but failed to detect direct evidence of volcanic activity. It's only in recent years, thanks to more sophisticated satellites like the European probe Venus Express, launched in 2005, that clues hinting at ongoing Venusian volcanism have been discovered. Among these are temperature and brightness variations in specific surface areas, suggesting recent or ongoing eruptions. Additionally, volcanic gases such as sulfur dioxide, which have a short lifespan in the atmosphere, have been detected, indicating a continuous supply from an internal source. However, these are just hints and no concrete proof. This leads to the question, is it possible that with all the probes sent to Venus, we still can't definitively confirm the presence of ongoing volcanic eruptions? It seems perplexing, but perhaps this time we've got it. The evidence has been found, and we share the exciting details in this splendid video, a gift received 30 years after the old Magellan probe. For millennia, the true appearance of the planet Venus has been a mystery guarded by the toxic clouds shrouding its surface. Only in the mid-1970s, photographic images transmitted to Earth by a few landers, surviving more than a few minutes in the hellish environment conditions, finally revealed the reality beneath the guise of the beautiful morning and evening star. An infernal world. A flat and desolate landscape, swept by fierce winds and oppressed by a scorching and heavy atmosphere. An inhospitable environment likely unsuitable for any form of life. A genuine disappointment because in terms of size, mass, and orbital distance from the Sun, Venus could have become a planet with much to offer for potential life development. Recent simulations suggest that approximately 3 billion years ago, Venus might have had comfortable temperatures ranging from 50 to 20 degrees Celsius and a deep ocean of a couple hundred meters. Unfortunately, the biological prospects of the planet were then annihilated by an uncontrollable greenhouse effect. It's still unclear what events led to the drastic change of the planet, but many experts link them to a prolonged sequence of paroxysmal volcanic eruptions that 750 million years ago released a large amount of carbon dioxide, the greenhouse gas par excellence, along with water vapor. This hypothesis gained traction only in the early 90s, when the incredible radar images from the Magellan probe revealed the presence of thousands of unsuspected volcanic structures on Venus, all seemingly dormant, at least apparently. Since then, we've known that Venus is the planet in the solar system hosting the largest number of volcanoes on its surface. Distributed in several hundred clusters, more than 85,000 have been counted, with bases exceeding 1 kilometer in diameter. However, the total number, regardless of size, could easily be close to 1 million. It is estimated that there are over 1,600 active or potentially active volcanoes, varying in size and shape. Some are enormous, like Mat Mons, standing at 8 kilometers tall and 395 kilometers wide, perhaps the second largest in the solar system after Olympus Mons. Others are small and numerous, resembling shield volcanoes akin to those in the Hawaiian Islands. Some are singular and mysterious, with absolutely unique shapes and characteristics. Indeed, judging from the images provided by probes, Venusian volcanism differs from that on Earth, both in terms of methods and causes. Venusian volcanoes erupt with very fluid, silica-rich lava, forming long and thin flows called lava channels. These flows can reach up to 7,000 kilometers in length, covering vast areas of the surface. In addition to the imposing shield volcanoes, lava plains on Venus cover extensive areas, suggesting extensive volcanic eruptions in the planet's past. These plains, known as planidia, are composed of basaltic lava flows that have spread and covered the surface, creating a smooth and relatively flat landscape. The presence of these lava plains indicate a history of large-scale volcanic activity, further highlighting the unique geological nature of Venus. Other typically Venusian volcanic structures include calderas, coronae, arachnoids, and novae. The last three are not found on other planets. Calderas are objects where large magma intrusions have surfaced in the lithosphere, deforming the surface and producing tensions on the crust and compressions, ultimately creating fissures, concentric collapses, and crustal extensions. Often this has been associated with volcanic activity. In many cases, the magma has ceased to rise, cooling prematurely and causing the collapse in the upwelling chamber, forming a large circular crater or an elongated depression on the planet's surface called a caldera. Often found in highlands, calderas can be distinguished from impact craters by the lack of a rim and terracing on the inner walls. They also lack an inner ring and a high central massif and are not surrounded by ejecta rays. Structures like these do not exist on the Moon or Mercury, but on Earth there are several smaller examples, such as the Ngorongoro volcano in Tanzania. Coronae are large calderas enclosed by concentric collapses and rings, with radial lava flows. They are generally elliptical with a diameter ranging from 100 to 1,000 kilometers, although many fall between 200 and 250. Formed by magma jets, volcanic activity was essentially brief to give rise to the filling of the created basin. More than 200 coronae are known on Venus, many of which occupy the highest part of the plains in areas that have experienced significant crustal compression. Many are found in chains or small clusters around Beta Regio, Alta Regio, and Themis Regio. Arachnoids are named after spiders or spider webs and are considered the small-scale counterpart of coronae, sharing the same mode of origin. They're circular structures between 50 and 250 kilometers in diameter, showing rings that are completely enclosed radial features. They exhibit fewer signs of volcanic activity, and about 60% are present in 4 large clusters. Novae are surface fractures arranged in a stellar explosion pattern. Similar in size to arachnoids, many fall between 150 and 200 kilometers in diameter. They show small traces of volcanic activity, and more than 50 are known. They may represent the first stage of arachnoid formation. Chains of small craters are sometimes seen in crustal extension areas, resembling secondary impacts formed by the surface collapse. At this point, the inevitable question arises: is it possible that with all the volcanic structures that, until almost a billion years ago, brought rivers of molten magma to Venus, we now find ourselves contemplating a surface completely devoid of that vital breath that still manifests itself on Earth today? In other words, is it possible that Venus is now a completely dormant world? What made experts reasonably certain of this was the absence of the geological process called plate tectonics on Venus, which on Earth allows the heat from the core to reach the surface through fractures in the lithosphere, initiating many geological processes such as the formation of mountains, volcanoes, earthquakes, oceans, and continents. Before moving on, don't forget to subscribe to our channel if you haven't already. Make sure to hit the notification bell so you don't miss out on our daily videos. Here on Earth, the process works like this. The heat from the Earth's core is released first to the surrounding mantle and then to the crust, ultimately dissipating into space. This continuous exchange of heat causes the movements of tectonic plates, representing the mechanism through which Earth cools down, utilizing magma brought to the surface through volcanic conduits that thicken along the contact zones of continental plates. On Venus, however, there is no evidence of this phenomena, or at least not as we know it on Earth. Venus's crust is thicker and hotter than Earth's and does not fracture into continental plates that move against each other. Additionally, the lack of water makes the crust and mantle more viscous and less deformable. This means that the planet's internal heat cannot be easily dissipated through the surface, accumulating until it reaches a critical point. At this juncture, a phase of global renewal is triggered, where the crust melts and reforms, erasing traces of the past. This process might occur every few 100 million years, explaining why Venus's surface is relatively young and homogeneous. In essence, for these and other reasons, until recently, most experts were decidedly skeptical about the possibility that Venus was still a geologically active world like ours. Only in recent years, thanks to more sophisticated satellites like the European probe Venus Express, launched in 2005, clues suggesting that Venusian volcanism might still be active and have emerged. Among these are temperature and brightness variations in certain surface areas, which could be due to recent or ongoing eruptions. Additionally, volcanic gases such as sulfur dioxide, which have a short lifespan in the atmosphere and must be continuously replenished from an internal source, have been discovered. So what generates so much heat capable of periodically melting Venus's surface? One of the most widely accepted hypotheses is that the heat is produced by large amounts of radioactive material in the mantle. Continuous heating due to the decay of radioactive materials would give rise to sporadic volcanic phenomena, while simultaneously producing such large amounts of magma that once every 500 million years, the entire planet's surface would be completely reshaped by cataclysmic eruptions. After decades of doubts and scientific controversies, in 2023 we finally obtained direct and decisive evidence for this hypothesis. This achievement was made possible by the re-examination of old photographic images taken by the Magellan probe. Geophysicist Robert Herrick, University of Alaska Fairbanks, and engineer Scott Hensley, Jet Propulsion Laboratory, NASA, decided this year to re-evaluate radar images of Venus's surface collected by the Magellan probe between 1990 and 1992. They wanted to ensure there were no yet unnoticed signs of Venusian volcanic activity. During the mission, the Magellan probe had used radar to map the planet's surface from various orbits, observing some areas 2 or 3 times over 2 years, including areas later identified as potential sites for volcanic activity. Herrick and Hensley had to manually analyze the full-resolution radar images to check for any changes in morphological features between radar passes. They were able to identify a volcanic vent, part of the larger Mat Mons volcanic system, that appeared to enlarge and change shape between 2 radar images taken 8 months apart. In the older images, the vent is almost circular, 1.5 times 1.8 kilometers, with steep inner edges. In the more recent images, the structure appears to have almost doubled in size and has an irregular shape. According to the authors, this could be a sign of filling with new material, likely due to a lava lake formed during the 8 months between the 2 captures. No other processes on Venus are known to produce what was observed. However, a single case does not allow for the determination of how common active volcanism is on Venus. On Mars, volcanic activity seems to have stopped millions of years ago, and no signs of contemporary activity have emerged despite decades of continuous observation from orbiting probes. On Venus, as we have just seen, only one structure has been identified in just a few years of data. The same system would have revealed a large number of eruptions if it had observed Earth. This would mean that Venusian volcanism is currently much less active than on Earth. However, it should be noted that the research conducted by Herrick and Hensley has examined only 1.5% of the surface so far, and the investigation has been based only on low-resolution images. Things will change significantly in the near future when NASA's Veritas probe between 2028 and 2030 maps the entire surface of Venus at high resolution using synthetic aperture radar. A bit more patience, and we will finally know if Venus truly deserves the moniker of the infernal planet that we have called it over the last 50 years.